Hello and welcome to this lecture. In this lecture, we are going to study the difference between having objects and having data structures. Yes, we are going to see how the API exposed by a class and its instances affects how the client uses them and how our code is structured. The goals for this lecture is to see clearly the difference between having an object and a data structure. Because if you have an object, you will have an API, you will expose an API, and we will see the difference of having a poor and a good API. APIs are an important element in object design, and it encapsulates how the objects are used and how the client interact with them and what are the responsibilities that we can delegate to the objects and what are the responsibilities that remains in the client, in the users of this object. We are going to look at two concrete examples. We are going to analyze the implementation of point in Java and in Pharo and how the difference in their APIs, how affect the final user and the code that uses these objects. First, let's start seeing what we have in the Java points. If we get this information from the documentation of Java, we see that points understand a series of messages. Basically, they have a way of getting a location. Basically, a point will return itself as the location of a point is just a point, so it returns self. It has a way of setting this location. In Java being a strongly typed language, we have different implementations of this method depending on the type of the arguments, but basically we have a way of setting the coordinates of the point using or doubles or int or another point. And also we have a way of accessing these two coordinates. If we see a little more of what we have in the API, we see that we can compare two points to see if they are equals, and we can move a point to a given position. We can set a new position to this point in the coordinate plate, and we can translate it by a distance. Translated it will modify its x and y coordinate, adding them the distance in x and y that we pass as parameter. Also, we have implemented, because we inherited with from the superclass point2d, the distance and clone methods. The distance tells us the distance from a point to another given point. As we can see, the implementations of points in Java is a super poor data structure. We have only methods to access to their contents, in this case the instance variable x and y, and it only works to hold two integers. It is super limited, the interface, or what we can do with a point. What are the messages we can send to a point and what are the operations that we can do with them. Basically, Java points are basically data structures. Let's see another example, the implementations of points in Pharo. We will see that it has a really rich API. We have selected some of the messages that we can send to a point, but we can see that we have a selection to operate on them, to normalize, transpose, on reflect about another point, different ways of calculating distances. We have the cross product and the dot product. We have a lot of mathematical operations on top of points. We can sum two points. We can multiply a point by an scalar, and we can calculate the division between a point and a scalar, so it will change its size. And we have comparison messages, so we can compare a point to another point, and we can compare points also not only using absolute values, but also using close to and different levels of precisions. And we have a lot of operations related with geometrical operations, like calculating the triangle area or obtaining a rectangle from a given point or for a given pair of points. So we have a really rich API. And if we continue seeing, they have operations to calculate the angles that these points have with the origin, or we can have calculate neighbors points or the directions or vectors in the different directions from this point. So we can see that we have a really rich API that the client can use and operate on points. Let's see a simple example that shows why we want this rich API and rich operations from the client point. Let's imagine we want to implement the cross product. It's quite easy, as we can see the implementation in Pharo. It's quite easy. It's a really simple implementation, but it's still useful. We can use it without knowing the implementation. The client does not know how to implement it. We don't need to duplicate it, and more, when we see calculation of the cross product, it's not evident for the reader of the code that is the cross product, but when we see the sending of the message cross product : we see clearly that we are doing this operation. So it's really good not to duplicate the code in client, but also as a way of documentation is more clear when we read the code. The same happens when we are comparing 2 points. In the implementation that we have already in the class point, we are handling the case of comparing the x and the y variable. Again, it's simple to implement in the client, but we don't want to. And this case gets even more and more interesting when we have an implementation of an operation that is more complicated. In this case, like the degrees message that will return us the angle that the receiver, the point receiver and this message, do with the origin. As you see, we have a lot of operation depending if the value of x, it has different conditional code, and also it has to handle the conversions of radians to degrees, and basically it's quite an interesting method that we don't want to re-implement in the clients. So let's see an example in Java to make it more clear why having a nice API, having a good API can impact the client. We want to make a little class that represents a robot, and it has a position, and we want to implement in it a go message. We will implement the go method, and we will pass an instance directly to this go method. So the new position of the robot, we will need to create a new point with the 2 values, because we cannot have other way of creating points. Just we need to give the x and y coordinate. We cannot operate with points. So we have to do all the calculation in the client side. You can tell me that this code, you can say that it's simpler or complex, but we have to do it all in the client side, in the user of the point. We have, as I say, we have to recreate this point explicitly using the distance and the current position. And we have to have all the arithmetic, all the operations that we are using with points outside the point. We have to write it every time we use a point. So this really shallow API that exposed in Java tends to generate duplication of code or logic duplication in all the clients that are using them. If we see it in a diagram, we see that in the implementation in Java where we don't have the degrees, we will have to implement this method degrees in each of the clients, having not only 4 times the same code, but also the opportunity to implement it wrong. What happens if one of the clients does not cover all the cases that is implemented for implementing this operation? So having a more complex or a more rich API in point, as we have in Pharo, allows us to reuse this code better and take responsibility out from the client. Even if they are simpler methods, we want to take responsibility out to ease the use of our objects. If you see now the implementation, or comparing the two implementations, on top we have the implementation in Java, and on bottom the implementation in Pharo, we see that the implementation in Pharo, as we have a rich operations in our point, we can take the initial position and add another point. And this point, we can create it with the angle with the cosine and sine, and scale it by the distance, and then round it to make it an integer. As we see, all the operations, all the code is implemented using operations that we delegate to points, to number, and with that we can implement the method much simpler. Of course, this difference in complexity gets higher and higher when the operation that we are creating is more complex. In the Pharo example, we see that in Pharo points, we use the points more than a data structure. We send a lot of messages to them, and we let them implement advanced behavior. This functionality is not needed to be implemented in the client and is easy to reuse because our points are better units that we want to use. So, as a conclusion, you have to remember always that objects are much more than data structure. Yes, the part of the holding the instance variable is just a part of the object, and usually is the less important. The most important is what are the behavior and services the objects do to their clients. What is the API they expose? The objects should give operations that we use from outside, and it should encapsulate the logic and its internal state. So the client can reuse this code, reuse the code that is implemented in the object, the operation that is exposed by the object, directly without caring how it is implemented.